Let us look a little more closely at numbers and how we come to understand numbers. If I say that this is a 1 and this is a 2 and this is a 3, there is absolutely no way we would understand what we're talking about here. When we see a 1, we might think that a 1 relates only to apples. When we see a 2, we might think that a 2 relates only to apples. And when we see a 3, we might also think that a 3 relates only to apples. Now, if I came in here and I did this, and I circle this apple and I say this is a 1, and I come and I circle this aeroplane and I say this is a 1, now the pattern basically is showing us that the aeroplane and the apple are not exactly the same item. But we have a 1 here that is relating both the apples and the apple and the aeroplane together. So likewise, if I come in here and I select these apples right here, and I put a 2 next to it, and I select these aeroplanes right here, and I have a 2 right next to it, then again we are seeing a pattern. That the pattern is not really the apple or the aeroplane, but it's something beyond that. So now when we come in here and we select this, and we put a 3 next to it, and we select this, and we put a 3 next to it, now it becomes all the more clear that we're not talking about the aeroplane nor the apple, but we're talking about the arrangement of aeroplane and the arrangement of apples. In other words, we're talking about what we call quantity. Which deals more with a collection as opposed to the items themselves. So if now I select this and I say a 1 here, and then I select this and I have here a 2, you start to notice that I did not put a 1 next to the apples. I placed a 2. So the numbers are different. But if I come in here and I select this, and I have a 3, and then I come in here and I select this, and I have a 3, there is a similarity between these aeroplanes and these apples. And now we start to get in our minds this picture of numbers, that numbers are not really talking about a specific item, but really how the items is being viewed. In other words, a property that is common between different items. And you can do the same thing with colors, for example. If I come in here and I select this color, and then I come in here and I select this color, and I say different, and then I come in here and I select this color, and I come in here and I select this color, and I say same. See, now what we have here is a word, and what we have here is a picture of an item. So even though they are both different, this is an aeroplane and this is a word, store, yet I'm saying that there is something about the two of them that is the same. And then, of course, if I continue this process and I show other things that are the same or other colors that are the same, then suddenly we start to get this picture of things that are similar in terms of color. So, this whole idea about selecting patterns, as we did in the case of the numbers, the aeroplane, and the apples, and then in another instant, we're not selecting patterns, okay, or sort of like the way the items are assembled, okay, or the way the items are grouped. And notice that it's not just a group in a particular order. We're not coming in here, for example, and doing this. And then what we have is, well, we know that these aeroplanes are in a horizontal line, a straight line, and these apples are in a straight line, therefore that must be 3. We're not doing that. What we're really doing here is this. We're coming in here and we're selecting the apples like this. The apples could be like in this arrangement right here, like a triangle, and it makes no difference. And yet we can still say that this is a 3. Just like we can come in here now, we can say this is a 3. So the pattern we're talking about here is not that they have to have the same shape or the same layout, but that there is something about the objects themselves. So we have one object here, we have another object here, and we have another object here. Then here we have one object, we have another object, and we have another object. So there are these type of similarities we are seeing that is sort of like a different similarity. So when we look at numbers, we're looking for certain things, certain attributes, certain characteristics, certain things that are unique between two different types of objects, the apples and the aeroplanes. Whereas when we're looking at colors, we're looking at again something completely different. And so when we're dealing with mathematics and numbers, we have to recognize that there are certain patterns that we start to observe with numbers. And it's not always thinking academically when it comes to mathematics, but we have to start to look at things with our eyes and say, am I noticing something really interesting here in terms of how the numbers are arranged? And then that would give us a very good sense of certain unique attributes, unique features of numbers that start make it those unique features and those unique attributes gives us an insight about those numbers that is different from the type of things we think about if we're just looking at objects. If you're just looking at like a boat in the ocean, or you're looking at a bird that's flying, that's different from really looking at two things and comparing those things. So mathematics really has a lot to do about comparisons. So when we come in here and we say that this is a 2, see, and then I come in here and I say this is a 2, see, and I come in here and I say, see this, and I say 2 here. What am I talking about, this 2? Okay, I'm talking about two numbers. The number 5 and the number 6. I'm not adding them up and saying 5 plus 6 is equal to 11. I'm just saying that these are two separate numbers. See that? Then I can come in here and I can see a word like this, and I can come and I can do this, and we have two letters. We have the letter O and we have the letter N. So when we're doing mathematics, we have to start to look for things as if we are paying attention, as if we're observing. It's like, what can I notice about what I'm looking at right now? And you start to think about it. So mathematics involves a lot of thinking, seeing things and relationships that normally you're not used to looking for, but now you start to form the habit of looking for those things. And suddenly you find out that that way of looking at things will start to develop mathematical ability. So again, this is an interesting perspective on numbers and how we come up with the idea that this arrangement of items is a 2, and how we can come and look for similar arrangements. So if I come in here and I do this and I put a 2 next to this, it's like, no, that is not correct. That cannot be a 2. Okay, but we're looking for this arrangement right here. See that? Or for example, I can come in here and I can say this. See these apples? I can say a 2. If I come in here and I do this, notice that? I can now say 2 here. See? So even though I'm taking a 2 from this set of aeroplanes that we call 2, and then part of it from this set of aeroplanes that we call 3, but I'm going in a different arrangement, still the idea, the concept of 2 applies. So if I come in here, for example, and I say we have this apple, and this apple, even though this is on the ground, and I say 3 here, and I come and I ask myself, how many aeroplanes have I selected here? I select this one right here, I select this one right here, and I select this one right here. You say, aha. Let's see. You see that? And then here, I can say, hear the sound of my voice. Here, So that sounds like the same quantity. But if I do this, I say, and then I come in here, and I do this, I say, Even the sound of my voice is different. And it starts to tell us that, there's something different about the selections right here. So we have to start to train our minds to start to look for unusual things. And some of these things, you don't require training. If you start to use your mind, you might come up with new ideas about numbers that no one else has thought about. And that's what mathematics is all about. There has to be a certain level of individuality. Things that you can figure out that maybe no one else has figured out. And it gives you a special pleasure that, wow, I was able to figure this out by myself. Not everything that you learn, you necessarily have to be told. There are some things that you can actually figure out yourself. Someone else might know the same thing, but you may not have been taught it, and yet you came up with the same answer, the same result as someone else. So it makes the whole field of mathematics very interesting, and we should really approach math from this standpoint. And when we do that, the word we can describe what we're doing here is called creativity. See that? And from that, we can invent things. Invention. So anyway, this is a unique way of looking at mathematics and how we can approach new ideas and new concepts in math, and how we should really allow ourselves to be inventive so that we can really take what it is we are learning and then discover new things in the process.